Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 2 in a session October-November 2023 Paper 2-3. So let's start with the first question. Question number 1, the function f and g are defined as follow for all real values of x. Find number A, find f composition g of 0. So first we have to find what is f of g of 0. So this is f of g of 0 is e 3 into 0 minus 1. So this would be f of e power 0 minus 1. So this would be f of e power 0. Anything power 0 is 1. So it's 1 minus 1. So basically this is f of 0. F of 0, this is equals to 2 sine 0 plus 3 cos 0. Sine 0 is 0, cos 0 is 1. So 2 into 0 plus 3 into 1. So the answer is just 3. Right. Now for part B, find g of x. Right. So we have g and g of x is e 3 power x, e power 3x minus 1. And g of this would be e 3 into e power 3x minus 1 into minus 1. Right. Now for part C, solve the equation g inverse of x equals to 1 by 3 ln 5. So first we have to solve for g inverse of x, right? So y equals to g of x, which is e power 3x minus 1. Switching the variables, x equals to e power 3y and minus 1. Now let me solve for y. So x plus 1, this is equals to e power 3y. And taking natural log on both sides, so we can say ln x plus 1, this is equals to 3y ln of e is just 1. So here we can say y is equals to, this is 1, so y equals to 1 over 3 ln of x plus 1. So this y is basically g inverse of x. Right, now g inverse of x equals to this and we have to solve for x. Okay, so g inverse of x is 1 over 3 ln of x plus 1. We have to put this equals to 1 over 3 ln 5. Right, 1 by 3 is cancelled with 1 by 3. Ln is cancelled with ln. So x plus 1 equals to 5. So x equals to 5, take away 1. So x is equals to 4. Right. Question number 2, find the values of k for which the curve is completely above x-axis. Completely above x-axis, the curve is quadratic, so the graph is a parabola, right? So for the parabola, it has one solution, two solution, or no solution, right? So one solution means one x-intercept, two solution means two x-intercepts, and no solution when no x-intercept. So it is completely above x-axis. So above x-axis means it has no solution, right? Or we can say when the discriminant is less than 0, right? So we can say discriminant is b square minus 4ac. This should be less than 0, right? B is k, so k square minus 4 times a, and the c is 4k and minus 15. This is less than 0. So k square minus 16k and plus 4 times 15. 4 times 15 is 60. This is less than 0, right? Okay, so let me factorize. 1 times 60 would be 60, and 6 times 10 is 60, and negative 6 negative 10 is negative 16. So k square minus 6k minus 10k plus 60 is less than 0. So k is common, we are left with k minus 6. Negative 10 is common and we have k minus 6. This is less than 0, right? So here we have two roots, k minus 6 and k minus 10. This is less than 0, right? So here we have k is equals to 6 and k is equals to 10. So it is less than 0, and it's a quadratic equation in a variable k, and k square coefficient is positive, so the opening of parabola is upward. Okay, so let me draw that parabola. The opening should be upward. If I can draw this. Okay, so this is the opening of the parabola, and the roots are 6 and 10. Okay, it is less when it is less. So it is less when the value of k is between 6 and 10. So the values of k which satisfy the inequality when the curve is completely above x-axis is 6 is less than k is less than 10. Right. Question number 3, part A, solve the following simultaneous equations. So log base 2x, log base 2y, right? So let me multiply the first equation by 3 and the second equation by 2, right? So we have 3 times 3 is 9 log 2x, 2 times 3 is 6 log 2y equals to 3 times 24, 72. 2 times 5 is 10 log 2x minus 3 times 2 is 6 log 2y, and 2 times 2 is 4, right? Now let me add the two equations. After adding the two equations, as you can see, log 2y's cancel out, and here we have 19 log 2x, and this would be 72 plus 4 is 76. This is 76, right? Now we can say log 2x equals to 76 over 19. 76 divides 19, this is 4, right? And x is equals to 4 square, so x is equals to 16. We got the value of x, right? Now same way we have to solve for y. So we have x, so log 2x is 4, so substitute into the first equation 3 log 2x, this is 4 plus 2 log 2y equals to 24. 3 times 4 is 12 plus 2 log 2y, this is 24. 2 log 2y, this is 24 minus 12, this is 12. So log 2y is 12 over 2, which is equals to 6, right? Okay, so now y is equals to 2 to the power of 6. The base is 2 and its power is 6. So 2 exponent 6, this is 64. Okay, I did the mistake over here. So x should be equals to, from here we have 2 to the power of 4. So 2 power 4 is 16. So x is 16 and y is 64. So this is a way to convert the logarithmic to exponential form, right? Now for part B, solve the equation. Let me simplify this first. 2 power is t plus 4 and minus 1 and plus 2t. Switching the power of the denominator, this is 512. So 2 to the power of 3t and plus 3, this is equals to 512. What is 512 to the power of 2? 2 to the power of 8, 2 to the power 9 is 512. Okay, 2 to the power 3 is common, t plus 1. This is 2 to the power of 9. So when bases are same, we can compare the powers, right? So 3 into t plus 1, this is equals to 9. 3 times 3 is 9. So t plus 1 is 3 and t equals to 3 minus 1, which is 2. So the answer is 2. Question number 4, find the exact value of this integral, right? So 3 to 5, opening the square, x square minus 2x plus 1 over x cube. This is dx. Okay, so from 3 to 5, x square over x cube minus 2x over x cube plus 1 over x cube. This is dx. right? Okay, so x square with this x square over here, what is left? 3 to 5, this is 1 over x minus 2 over x square plus 1 over x cube into dx, right? Or we can say 3 to 5, this is 1 over x minus 2 x to the power minus 2 plus x to the power minus 3. This is dx, right? Now let me integrate this. 1 over x integration is ln x, natural log of x, minus 2 x to the power minus 2, its integration is x power minus 2 plus 1 over minus 2 plus 1, plus x to the power minus 3 plus 1 over minus 3 plus 1, and the limits from 3 to 5, right? First simplify and then we can substitute the limits. Ln x, okay, so this is minus times minus, this is x to the power minus 1 over minus 1, so minus 1 and this minus becomes plus, so 2 over x, right? And this is negative 2 and negative 2, so 1 over negative 2, 1 by 2, yeah, and x square, right? Now applying the limits from 3 to 5 and simplify, right? So ln 5 plus 2 by 5 minus 1 by 2, 5 squared is 25. This is the upper limit, minus the lower limit is ln 3 plus 2 by 3 minus 1 over 2, 3 squared is 9, right? For this simplification, ln 5 plus 2 by 5 minus 1 over 50 minus ln 3 minus 2 by 3 and plus 1 over 2 times 9 is 18, right? Okay, so ln 5 minus ln 3, so this would be ln of 5 over 3, right? And simplify the fractions. We have 2 by 5 minus 1 over 50 and minus 2 by 3 and plus 1 over 18. This is minus 52 over 225, minus 52 over 225, right? Question number 5, the curved surface area of a cylinder with the radius r and height h is 2 pi rh, right? This is the curved one. The closed cylinder has a radius r centimeter and the volume is 1000 centimeter cube. Number A, show that the total surface area of a cylinder is this much. Okay, so the volume we have given, the volume is equals to pi r square h. This is the volume of a cylinder. The volume is 1000. This is equals to pi r square h. Let me solve for the height, which is 1000 over pi times radius square. This is the height, right? Now let me find the total surface area of a cylinder. The total surface area is equals to 2 pi r square plus 2 pi r h. H is 1000 over pi r square, right? So cancel the pi with pi, r with this r. So we are left with 2 pi r square plus 2 times 1000 is 2000 over r centimeter square. This is the total surface area of a cylinder. Right, now for part B, find the value of r for which makes this area a minimum. The area is minimum, it means the derivative of area should be equals to 0. And we have to solve for r. You should show that your value of r gives a minimum of this area. We have to show as well, right? So first we have to differentiate the surface area, right? So the surface area we have given is 2 pi r square plus 2000 over r, right? So let me do dA over dr. This is equals to 4 pi r, right? And minus 2000 over r square. we have to put this equals to 0 to find the maximum or the minimum, right? Now let me solve for the radius. Okay, so this is 4 pi r equals to 2000 over r square. So r cross multiplication, r cube equals to 2000 over 4 pi. Okay, so 2000 divides 4 pi, and cube root of answer is 5.41. R is equals to 5.42 if I round it to 2 decimal place. This is the radius. Now we have to show that this value of R gives the minimum of the area. By second derivative test, we can show when the second derivative is positive, it gives the minimum area. Now let me differentiate d2a over dr square, the second derivative. So its second derivative is just 4 pi, right? And this is plus 2000 over r cube. This is the second derivative, right? Okay, so we have power 2 as well. So we have 2 times 2000 would be 4000, right? So substituting the value of r, which is 5.42, so d2a over dr square at r equals to 5.12, we have 4 pi plus 4000 over 42 whole cube, right? So this is 5.42, it's cube. 4000 divides answer and add 4 pi. This is 12 pi, 37.7, and this is positive, greater than 0. So it is proved that the value of r, which is 5.42, gives a minimum of this area. Question number 6. A particle travels in a straight line, its displacement as meters from origin at time t second, where t is greater than 2, is given by. This is the displacement. Part A, find the expression for the velocity v meter per second and acceleration a meter per second square of the particle, right? So first we have to find out the velocity. Velocity is the derivative of displacement with respect to time. So the derivative of ln of x is 1 over 4t square minus 5, and for this 4 into 2t, so 2 times 4 would be 8t, and the derivative of minus t is just minus 1. So this is 8t over 4t square minus 5 and minus 1. This is the velocity, right? Now let me solve for acceleration. Acceleration is the derivative of velocity with respect to time, right? So we have to differentiate this. For this we have to use a quotient rule over here. So the denominator function is as it is, right? The derivative of numerator function is 8 minus the numerator function, and the derivative of denominator function is 2 times 4 is 8, and t over the denominator function square. Or you can simplify or keep it as it is. This is to you. Now for part B, find the value of time when the particle is at rest. The particle is at rest when the velocity of the particle is 0. The velocity is equals to 0, right? We have to solve for the time. This is the velocity of the particle, and we have to put it equals to 0 and solve for time. So 8t over 4t square minus 5 minus 1, this is equals to 0. So 8t over 4t square minus 5, this is equals to 1, right? Now let me do the cross multiplication. So 8t equals to 4t square and minus 5, or we can say 4t square minus 8t minus 5 equals to 0, right? I just shifted this 8t on the other side. Now it's a quadratic equation and a variable t. So let me factorize this. 4 times 5 is 20. Okay, let me make the factors of 20, which make 8. 2 times 10 is 20, and 2 minus 10 is 8, negative 8. 4t square plus 2t minus 10t minus 5 equals to 0. So 2 and t is common, so we are left with 2t plus 1 minus 5 is common, 2t plus 1 equals to 0. The two factors are 2t plus 1 and 2t minus 5 equals to 0, right? Put both factors separately equals to 0 and solve for time. So 2t plus 1 equals to 0. So from here t equals to minus 1 by 2, and this is not possible. Why? Because time never be negative, right? Now the second one is 2t minus 5 is equals to 0 and the t value is 5 by 2. This is possible. So this is the value of time, 5 by 2, which is 2.5 when the particle is at rest. 2.5 seconds we can say. Now for part C, find the acceleration at this time. So at this time, at t equals to 2.5 seconds, we have to find the acceleration. So the acceleration we got in the first part, which is this. So let me substitute the value of time over here. 4 into 2.5 square minus 5 into 8 minus 8 times 8 is 64, and t times t would be t square over 4 2.5 square minus 5 and its whole square, right? Let me simplify this. 2.5 square times by 4 subtract 5, this is 20, times by 8, which is 160. 2.5 square times 64, which is minus 400, over 4 times 2.5 times 2.5 and subtract 5, its square, 400, right? So 160 minus 400 divides 400. This is negative 3 by 5. This is the value of acceleration at that time. Question number 7, do not use a calculator in this question. Number A, given that the area of a triangle ABC, the area of a triangle we have given, show that sine 75 degrees is this much, right? So you may use the following trigonometric ratio. Okay, 60 and 45 we have given. Okay, so area of a triangle ABC. So as we know that the area is 3 plus square root of 3 divides 4. This is half measure of two sides, which is square root of 2 and BC, and sine of angle 75 degrees, right? So first we have to solve for BC. Okay, so let me solve for BC. So to get BC, first this is BC. Okay, it's angle, and let me apply law of sine over here. So law of sine, it says BC over sine of 60 equals to square root of 2 over sine 45. We have given sine 60 and 45, right? So here we have BC equals to square root of 2 over sine 45, which is 1 over square root of 2 times sine of 60, which is square root of 3 by 2. Okay, or we can say square root of 3 divided by 2 times square root of 2 and the reciprocal, which is square root of 2 over 2, right? Sorry, we have to reciprocate this because BC is square root of 2 stays the same, and square root of and sine 60, which is square root of 3 over 2, and sine 45 is a reciprocal, so it is 2 square root of 2. This is 2 and this is square root of 2, right? So 2 is cancelled with 2, square root of 2 is cancelled with square root of 2, so BC is just square root of 3. This is root 3, right? Now let me plug this into that formula and simplify. So we can say 3 plus square root of 3 over 4 equals to 1 by 2 root 2 root 3. This is equals to into sine 75 degrees. We have to solve for sine 75, right? Now from here, sine of 75 degrees, this should be equals to 3 plus root 3 over 4, right? And this term is divided on the other side, right? So this term is root 3 and okay, so times 2 over root 2 times 3 would be 6, right? 2 times 1 is 2, 2 times 2 is 4, right? And okay, to get that form, let me rationalize this. 3 plus square root of 3 over 2 square root of 6. Multiplying and dividing by 2 square root of 6 over 2 square root of 6, right? So this would be 3 times 2 would be 6 square root of 6 plus 2 square root of 3 into square root of 6 over 2 times 2 is 4 and root 6 square, right? 6 root 6 plus 2, this is 3 times 6 is 2 times 3 over 4 times 6, because square root on square is cancelled. 4 times 6 is 24, right? So it's 6 root 6 plus 2. We have a square of 3 and 3, so we can take 3 outside, and we have root 2 over 24. Okay, 6 root 6 plus 6 root 2 over 24. Let me take 6 common from the numerator. So 6 is common. We are left with root 6, root 2 over 24. 6 times 1 is 6. 6 times 4 is 24. So this is root 6 plus root 2 over 4. This is sine 75 degrees. We have to prove that this. So root 6 root plus root 2 over 4, right? Now for part B, hence find the exact length of AC. The exact length of AC we have to find, right? Let me apply law of sine over here, right? AC over sine 75 and square root of 2 over sine 45, right? So we can say AC over sine 45 equals to root 2 over sine 45. So what is AC? AC is root 2 times sine 75 over sine 45. Right. So this is root 2 times, what is sine 75? We got this in the A part, which is root 6 plus root 2 divides 4. And 1 over sine 45 would be 2 over square root of 2, the reciprocal, 2 over root 2. So root 2 is cancelled with root 2. 2 times 2 is 4, right? So the simplified form is root 6 plus root 2 divided by 2. This is AC. Question number 8, part A, show that the left hand side equals to right hand side. Okay, let me start from the left hand side. Sine x over tan is sine over cos minus 1 minus cos x over sine over cos plus 1, right? So here we have sine x over sine x minus cos x over cos x minus cos x over sine x plus cos x over cos x, right? Further simplification, sine x into cos x over the reciprocal sine x minus cos x. minus cos x into cos x would be cos square of x over sin x plus cos x, right? Let me take LCM. So this is sin x minus cos x, so we have to multiply the opposite denominator. Sin x cos x is going to multiply with sin x plus cos x minus cos square x is going to multiply with sin x minus cos x over sin x plus cos x into sin x minus cos x. So we have sin square x cos x plus sin x cos square x minus sin x cos square x minus cos cube x, and in the denominator we have sin square x minus cos square x. So sin and cos square with the plus minus is cancelled. We can say cos is common, taking cos common, cos x is common. So negative times negative, this is positive, sorry. So cos is common from here. We are left with sin square of x and plus cos square of x over sin square minus cos square. Sin square x plus cos square x is equals to 1. So we have only cos x over sin square x minus cos square x. This is my right hand side. It is proved. Cos, sin square and minus cos square. Now for part B, hence solve the equation. This equation equals to 1 for x is between 0 to 360 degree. So this is the left hand side of part A. The right hand side is basically, we can say, cos x over sin square x minus cos square x. This is equals to 1, right? Cross multiplication, cos x equals to sin square x minus cos square x. Let me convert everything into cos. So cos x, sin square is 1 minus cos x, cos square x minus cos square x. So cos x equals to 1 minus 2 times cos square x, right? So let me shift all this term to the left. So 2 cos square x plus cos x minus 1 equals to 0, right? Now let me factorize this. 1 times 2 is equals to 2. So 2 minus 1 is 1. So 2 cos square x plus 2 cos x minus cos x minus 1 equals to 0. 2 is common and cos x is common. We are left with cos x minus 1 plus 1. Minus 1 is common. Cos x plus 1 equals to 0. The two factors are cos x plus 1 and 2 cos x minus 1 equals to 0, right? Now let me put both factors separately. Equals to 0 to solve for cos. So cos x plus 1 equals to 0 and 2 cos x minus 1 equals to 0. So here cos x equals to negative 1, and from here cos x is equals to 1 by 2, right? So cos x is negative 1. We have to solve for x, which is cos inverse of 1. What is cos inverse of 1? In degrees, yes. Cos inverse of 1 is 0. So x is equals to 0 degrees. Now using the cast rule, so we know that here cos is negative. Cos is negative in second and third quadrant, right? So we can say the second quadrant, its answer is 180 minus 0, right? Which is 180 degree. And in the third quadrant, it is 180 plus 0 is again 180 degree, right? Now for the next one, what is x? X is equals to cos inverse of half. Cos inverse 1 by 2, 60 degree. X is 60 degree. So here cos is positive in the first and fourth quadrant. So for fourth quadrant, we have to do 360 minus 60, which is 300 degrees. So the solution is 60 degree, 180 degree and 300 degree. Question number 9. A curve has an equation y equals to x e power 2x. Number A, find dy by dx. So dy over dx is the product rule. First function is as it is, derivative of second function, plus second function is as it is, derivative of first function, which is 2x e power 2x and plus e power 2x. Right. Now for part B, find the equation of normal to the curve at x equals to 1. Right. For equation of normal, we have to find dy over dx at x is equals to 1. So 2 into 1 e power 2 into 1 plus e power 2 into 1. So this is 2 e square plus e square. So this is 3e square. Right. So we have x equals to 1. What is y? So y at x is equals to 1 is 1 e power 2 into 1. So e square is the y. Right. So now let me write down the equation of normal. Equation of normal is y minus y naught equals to minus 1 over y prime at the point into x minus x naught. Right, x naught and y naught. X naught is 1, y naught is e square. So y minus e square equals to negative, and its reciprocal, minus 1 over 3 e square into x minus 1. So that is the equation of normal to the curve at x equals to 1. Now for part C, use your answer to part A to find the exact value of this integral. The answer of part A is d by dx of x e power 2x. This is 2x e to the power 2x plus e to the power 2x. Integrate on both sides. Right, so this derivative integral is cancelled. X e to the power 2x equals to integration 2x e to the power 2x dx plus integration e to the power 2x dx. Right, so x e to the power 2x equals to integral to x e to the power 2x dx, and this integral is e to the power 2x over 2. Right, so from here we can say integration from 0 to 2 2x e to the power 2x dx. This is equals to, shifting that term on the other side, x e to the power 2x plus minus 1 by 2 e to the power 2x, because I shift it on the other side, and the limits are from 0 to 2. Okay, now let's apply the limit. The upper limit is 2 e to the power 2 times 2 minus 1 by 2 e to the power 2 times 2. This is the upper limit, minus the lower limit is 0. So x is 0, so it's just 0, minus 1 by 2 e to the power 2 times of 0. Right, so e to the power 4 minus 1 by 2 e to the power 4 and plus 1 by 2 e to the power 0 is just 1. Right, so that is e to the power 4 is 2 minus 1 by 2, 3 by 2, 1.5. So 3 by 2 e to the power 4 plus 1 by 2. This is a simplified answer. Question number 10, part A. In an arithmetic progression, the fifth term is 11. So fifth term is a plus n minus 1, 5 minus 1, 4d equals to 11. This is my first equation. And the seventh term is a plus 6d. This is 3 times of the second term, which is a plus d. This is my second equation. Now find the first term and the common difference. Right, we have to solve for a and d. A is a first term and d is a common difference. A plus 6d equals to 3a plus 3d. So we have a minus 3a plus 6d minus 3d. This is equals to 0. So minus 2a plus 3d. This is equals to 0. So this is my third equation, we can say. Now simplifying the first and the third equation. Okay, so let me multiply my first equation by 2 to cancel the a's and solving for g. So 2a plus 2 times 4 is 8d equals to 22, minus 2a plus 3d equals to 0. Add them up. So 8, 9, 10, 11. So this is 11d equals to 22. So d value is just 2. 22 over 11 is 2. So we got d equals to 2. Now substitute that d value into the first equation to solve for a. So a is equals to 11 minus 4d. 11 minus 4 times 2 is 8. 11 minus 8, so 3. So a is equals to 3 and d is equals to 2. The first term in the common difference. Now for part B, a different geometric arithmetic progression AP and a geometric progression GP have the following properties. The first terms of the arithmetic progression and geometric progression are both 3, right? The first term is the A. A is equals to 3 for both arithmetic and geometric. So arithmetic progression, we have a plus n minus 1 into d, and for geometric progression we have a into r power n minus 1, right? So we got a equals to 3, right? The second term of arithmetic progression is same as the third term of geometric progression. So second term of arithmetic progression is a plus d, which is 3 plus d. This is same as the third term of geometric, so 3 over here, so which is 3r square, right? Okay, now the sixth term of arithmetic progression, which is 3 plus 5d, is the same as the fifth term of geometric, so 3r4, right? The common ratio of geometric progression is greater than 1. R is greater than 1. Find the common difference of arithmetic progression and the common ratio of geometric progression. We have to solve for D and R. We have two system of equations. We can easily solve it. Okay, so the first equation is, let me multiply the first equation by -5. Right. 3 times 5 is 15. So this is negative of 15, negative 5d, and negative 15r square. We have 3 plus 5d and equals to 3r power 4. Cancel it out, right? So from 15 take away 3, minus 12. And this is minus 15r square and plus 3r power 4, right? Simplify, we have 3r power 4 minus 15r square and plus 12. This is equals to 0, right? Let me divide throughout the equation by 3r, 4. 3 times 5 is 15 and 3 times 4 is 12, right? So factorize, we have minus 4r square minus r square plus 4. This is equals to 0. R square is common, r square minus 4 is left, minus 1 is common, r square minus 4. This is equals to 0. So r square minus 1 is the factor and r square minus 4 is equals to 0. These are the two factors, right? So from here, r square equals to 1 and r square equals to 4, right? Or we can say r equals to 1 and from here r equals to plus minus 2. So we have to pick the geometric progression common ratio should be greater than 1, not equals to 1. We have to pick the more than 1. So here r equals to 2, right? So we got the value of r, plug into the first or second equation to solve for d. So from here, d is equals to 3r square minus 3. So 3, 2 square and minus 3. So this is 3, 2 square is 4 and minus 3. 3 times 4 is 12. 12 take away 3. This is equals to 9. So the common difference is 9, right? So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.